Hello, this is teacher King David. We are going to study mathematics, unit 1, complex numbers. So we're going to look on complex numbers. A complex number is a number that can be put in the form of a plus bi. So which means that a complex number, it is where we can write z equal to a plus bi. So this is a complex number. But remember, before we studied a complex number, we studied a real number. So a set of real number is a subset of a complex number. So a set of real number is a subset of a complex number. So this is the notation of a complex number. The notation of a complex number, the notation of complex number is, this is the notation of a complex number. It is a notation of a complex number. So now, a real number is a subset of a complex number. I think you are getting me. So now, so you know, in a set of real number, when you're solving a set, when you're solving a question in a set of real number, for example, I have like x plus 2. Solve x plus 2 equal to 0. How can you solve that in a set of real number? Solve this on under set of real number. X plus 2 equal to 0. So it means that x will be equal to negative 2. So our set is, the value of x is negative 2. Are you getting me here? So here x equal to negative 2. So we are solving this one under a set of real number. So also, because a real number is a subset of a complex number, also we can say that solve z plus 2 equal to 0 under set of a complex number. So meaning that here z will be equal to negative 2. So our set here also is negative 2. So now what is the difference between a real number and a complex number? So the difference between a real number and a complex number is, so when we are solving a quadratic equation, for example, we have example solve in real number. Solve x squared minus 4x plus 4 equal to 0. So we're going to solve this one under set of real number. So I want to show you the difference between a set of real number and a complex number. So we have x squared minus 4x plus 4. So you know, we can use quadratic formula. Our a there is, our a is 1, coefficient of x squared. Our b is negative 4, coefficient of x. Then our c equal to 4. Then from quadratic formula, which is x equal to negative b plus or minus b squared minus 4ac divided by 2a. So now our x will be equal to b equal to negative 4 minus minus 4 plus or minus square root of b squared. Our b is negative 4. That's negative 4 squared minus 4ac. Our a is 1. Our c is 4. So 1 times 4, which is c. Divided by 2a. 2 times a, which is 1. So now our x is negative, negative becomes positive. So that is positive 4 plus or minus square root negative 4 squared, that is 16. Negative 4 times 1, that's negative 4, times 4, that's negative 16. Divided by 2 times 1, which is 2. So now 16 minus 16, that is 0. Square root of 0 is 0. So our x is 4 plus or minus 0 over 2. So here we have two values. We have x1 where 4 plus 0 over 2. So which is 4 over 2, where the answer is 2. And here we have 4 minus 0 over 2. So which is equal to 4 minus 0 is 4, divided by 2. Also the answer is 2. So now here, we have x1 equal to x2, which is equal to 2. So our set, it has 2 as a solution set. So now, we are solving this one under a set of real number. So now there is a question. That is, this question was number A. So B, how can we solve x squared plus x plus 1 equal to 0? So coefficient of x squared is 1, which is A. Coefficient of x here is B, which is 1 here. And a constant is 1, which is C. So we're going also to use quadratic formula. So now our x will be equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. So mean that it will be negative b plus or minus square root of b squared minus 4ac divided by 2a. So now x is negative 1 plus or minus root 1 squared minus 4 into 1, 1 divided by 2, 2 times 1. So here x is negative 1 plus or minus square root of 1 squared, it is 1. 4 times 1 is 4. 1 minus 4 divided by 2. So now x will be equal to negative 1 plus or minus square root of 1 minus 4, it is negative 3. 1 minus 4, it is negative 3 divided by 2. So now, the problem here is a square root of a negative number does not exist in a set of real number. So here, we are going to say that no solution in R. There is no solution in R because square root of a negative number does not exist. So that's the difference. But when you are in a complex number, it exists. So look, if we can solve in a complex number, x squared plus x plus 1 equal to 0. So immediately, we're in the same procedure. So when we reach here, x will be equal to negative 1 plus or minus root negative 3 over 2. But we know that negative 1 equal to I squared. That is addition to a real number. So that's what complex number brings. So when you have negative 1 as I squared, so it will help us to find the square root of negative 3. So here x will be equal to negative 1 plus or minus root, because negative 1 now is I squared. So I squared times 3, that is 3I squared divided by 2. So what does it mean? It means that x is going to become negative 1 plus or minus square root of I squared is I. That is plus or minus I root 3 divided by 2. So now our x1 will be equal to negative 1 over 2 plus I root 3 over 2. x2 will be equal to negative 1 over 2 minus I root 3 over 2. So now we have a solution set contains x1, which is negative 1 over 2 plus I root 3 over 2. x2, negative 1 over 2 minus I root 3 over 2. So that's how complex number help us to solve a equation that real number cannot solve. So now, as I told you that a real number is a subset of a complex number. So now, a complex number is a bigger set when you compare to a real number. So now, a complex number, it helps us to solve an equation that where we have a square root of a negative number, like here, square root of negative 3, because a negative 1 is I squared. So which means that when we have this negative, we're going to have I squared. And you know the square root of I squared, it is I. Square root of I squared is what? I. So now our set contains x1 equal to negative 1 over 2 plus I root 3 over 2, x2 negative 1 over 2 minus I root 3 over 2. So I think you are getting this one. So let us try to look at other examples about complex numbers. So we have, as I told you, how a complex number is a bigger set to a real number. So now we have three forms of a complex number. We have three forms of a complex number. So we have three forms of a complex number. So the first form is standard form. Standard form or Cartesian form or algebraic. Or algebraic form of a complex number. So we have standard form, Cartesian or algebraic. So that is the first form. Second, we have polar form or trigonometric form. They call it polar form or trigonometric form. So you may find that they are using trigonometric form. They can ask you, express algebraic form into trigonometric form. Or they can say polar form. So the number 3, we have exponential form. Exponential form of a complex number. So we're going to start with number 1, which is algebraic form of a complex number. So algebraic form of a complex number, that's where we have z equal to a plus bi. So where a, b are member of real number. A and b are member of real number. So this is the algebraic form of a complex number. So this algebraic form of a complex number, it contains real part and imaginary part. It contains a real part and imaginary part. So z, which is equal to a plus bi, it contains real part and imaginary part. So what is our real part? Our real part of z, it is a. What is our imaginary part? Our imaginary part of z is b. So what does it mean? The real part of Z, which is A, so it is a part does not contain I. Let me repeat. A real part of Z, a real part of a complex number, it is a part does not contain I. So imagine a part of Z, it is a part contains I. So which means that the imaginary part of Z, it is a coefficient of I. Let me repeat. Imagine a part of Z, it is a coefficient of I. I hope we are together here. So for example, examples here. Number one, write down the real part and imaginary part of the following complex numbers. So we have A, Z equal to 2 plus 3i. B, Z equal to 3i minus 4. C, Z equal to negative I. So let us try to write down the real part and the imaginary part of the following complex numbers. So for A, our A, Z equal to 2 plus 3i. Z equal to 2 plus 3i. Remember I told you that a real part of a complex number, I told you that from Z equal to A plus BI. I've said a real part of a complex number here is A. It is a part does not contain I. So imaginary part of Z is the part that contains I, which is B. So mean that is the coefficient of I. So now, if the real part of this Z is, it will be 2. So what will be the imaginary part now? What will be the imaginary part of that Z? So our imaginary part of Z, yes, it is 3, coefficient of I. So that's the answer. B, we have our B here. Z equal to 3i minus 4i. So now, what will be the real part of Z? So the real part of Z is, it is negative 4. Because this is the part does not contain I. So what is the imaginary part of that Z? The imaginary part of this Z is 3. Because 3 is the coefficient of I. So number C, we have Z equal to negative I. So the real part of Z is, so what is the real part of Z here? The real part of Z here is 0. Because here, it's like Z equal to 0 minus I. So when you compare this one with A plus BI, you see, our A will be equal to 0. So now, our A here, our real part of Z is 0. Because this Z is like 0 minus I. So then, what is the imaginary part of Z? So imaginary part, it will be the coefficient of I. So now the coefficient of I here is -1. So now it is -1. So imaginary part of Z is -1. I hope you are getting this one.